Picture a fly buzzing around your room. You swat at it. You already know exactly what happens next. It dodges and dodges again and again and again. Sometimes it feels almost supernatural, like the fly can see the future before it happens. It can't. But what's actually going on might be even stranger than prediction. That fly may genuinely be experiencing time more slowly than you are. Not science fiction, not Einstein's relativity, just the very real possibility that different animals process reality at fundamentally different speeds. To the fly, your hand might be moving through the air in what feels like slow motion. Which raises a bizarre question. What if time doesn't feel the same for every living thing? What if a second for a fly stretches out longer than a second does for you? What if a dog experiences now differently than a turtle does? What if entire animal lifetimes unfold at genuinely different speeds, depending purely on the brain doing the experiencing? It sounds impossible. A second is a second. The clock doesn't care who's watching it. But clocks measure physical time. The question scientists are actually asking is different. How fast does the brain experience reality? And the answer seems to vary wildly across the animal kingdom. The speed limit of reality. To understand why, start with a concept called temporal resolution. Think about watching a movie. The image looks smooth and continuous, but it isn't. A film is really just a rapid sequence of still frames, traditionally 24 of them every second, stitched together by your brain into the illusion of motion. Slow the frame rate down enough and the illusion breaks. You start seeing individual pictures instead of fluid movement. Now imagine every species has its own version of that limit, its own maximum speed at which it can sample and process reality. Scientists measure this using something called the critical flicker fusion threshold. If a light flashes fast enough, humans eventually stop perceiving individual flashes, and the light appears to glow continuously. For most people, that threshold sits around 60 flashes per second. But plenty of animals can detect changes far faster than that. Some birds can process over 100 flashes per second, and certain insects detect even more, meaning they're effectively receiving more visual updates from the world than we ever do. Think of it like upgrading from a 60 Hz monitor to a 200 Hz one. The same stretch of physical time passes either way, but the motion on screen looks smoother, more detailed, more precise. Reality itself seems to move faster. Researchers believe something similar plays out in animals with especially rapid nervous systems. The world isn't literally slowing down around them, but they're packing more information into the same slice of physical time. This may be exactly why flies are so maddeningly hard to swat. To us, a hand moving to strike looks fast. To the fly, that same motion may be unfolding across far more perceptual moments, more individual frames of opportunity to notice, react, and escape. In a real sense, the fly may be living through more experience per second than you are. Size, metabolism, and speed flies aren't alone in this. In 2013, researchers reviewing studies across dozens of species found a striking pattern. Smaller animals generally perceive temporal changes faster than larger ones. Mice process information faster than humans. Small birds routinely outperform larger mammals. Insects can be faster still. The likely reason is metabolism. Smaller animals tend to run hotter, faster metabolic engines. Hearts beating more rapidly, energy burning quicker, nervous systems firing at higher speeds. Life simply happens fast when you're small, and perception appears to speed up right along with it. Take a hummingbird. Its heart can beat over 1,000 times a minute. Its wings flap dozens of times every second, and its entire world demands split-second precision. Flowers have to be found instantly, predators avoided immediately, because the smallest delay can be fatal. Evolution appears to have equipped animals like this with nervous systems built to keep pace with the stakes. So what happens at the opposite end of the scale? The enormous, the slow-moving? Possibly something just as real, in reverse. Larger animals often process information more slowly, not because they're less intelligent, but simply because their bodies run on a different clock entirely. An elephant's heart beats far slower than a mouse's. Its movements, its metabolism, its entire life unfolds at a different tempo. Some scientists suspect larger animals may effectively register fewer perceptual moments per second than smaller ones. If that's true, an elephant's experience of the world isn't necessarily less rich or less detailed, just slower. A different rhythm entirely, not a lesser one. Mental time travel. But size only explains part of this story, because time perception isn't just about how fast the present moment gets processed. Many animals also seem capable of reaching beyond the present entirely, into the past and future. For a long time, the assumption was that animals live purely in the moment. Humans plan, animals simply react. That picture has gotten a lot more complicated. Scrub jays, for instance, hide food in multiple locations and appear to remember not just what they stored and where, but roughly when, retrieving food that spoils quickly earlier and food that stays edible longer at a more relaxed pace. Their behavior shifts based on how much time has actually passed, which some researchers describe as a primitive form of mental time travel. Other species show similar patterns. Chimpanzees have been observed saving tools for future use. Ravens plan ahead in ways that go well beyond simple instinct. Even rats show evidence of replaying past routes through their environment and simulating future ones in their minds. The deeper scientists dig into animal cognition, the harder it becomes to draw a clean line between how humans experience time and how other animals do. Why time speeds up as you age? Which leads to maybe the strangest question of all, one you've probably felt yourself. Why does time seem to speed up as we get older? Summer vacations felt endless as a kid. As an adult, entire years seem to evaporate. Christmas arrives shockingly fast. Birthdays pile up closer together, and the whole flow of time seems to accelerate with age. One leading theory centers on novelty. The brain pays disproportionate attention to new experiences. Children are constantly encountering new places, new people, new skills, and the brain lays down rich, dense memories to match. Adults live through far more repetition. Fewer individual moments stand out, so looking back, entire months blur together and compress into almost nothing. Now apply that same logic to animals. Many species live in environments saturated with constant novelty. Every scent trail different, every hunt different, every migration presenting a fresh set of challenges. Could that reshape how they experience the passage of time too? Possibly. Honestly, we don't fully know yet, and that's because time perception remains one of the genuinely hardest subjects in all of science. Researchers can measure behavior, reaction speed, and brain activity. But no one can climb directly inside another creature's mind and feel what reality is actually like from in there. Which brings us back to the fly. The next time you watch one dodge your hand with what feels like impossible precision, understand you're seeing more than a fast reflex. You may be watching a nervous system processing reality at a speed radically different from your own. A world broken into more perceptual moments, more individual slices of experience, more chances to react before it's too late. And the deeper researchers dig into this question, the stranger the whole picture becomes. Time may not be one single shared experience distributed equally across every living thing. Instead, each species may inhabit its own private version of the present, its own tempo, its own internal rhythm, its own personal speed of reality. A hummingbird, a tortoise, a dog, a mouse, and a human all share the exact same physical universe. The same seconds tick by for every one of them. And yet the evidence increasingly suggests those seconds don't feel remotely the same from the inside. The hummingbird's world may race by in a blur of urgency. The tortoises may drift, slow and unhurried. The fly may watch your hand approach in exquisite, frame-by-frame detail, while you barely register the beating of your own heart. Maybe that's one of the strangest facts about being alive at all. Not that animals experience a different world than we do, but that they may experience a fundamentally different flow of time itself. So the next time you miss swatting a fly, remember, it isn't predicting the future. It's simply living through more of the present than you are. If questions like this genuinely fascinate you, subscribe. There's a lot more hiding beneath the surface of how minds experience reality.